If you have watched my initial video, which I posted at the very top of the systems thing, what the heck is a system of equations or inequalities? If you have watched that, you probably already have a sense that a system of equations is a point that is the overlap or intersection between two or more equations, and that can be found oftentimes by graphing. So I've created a little scenario for solving systems by graphing. So we have the very slow northbound train. This is the opposite of an express. Leaves from the station 75 miles south of Dirty Sock, Arizona, which is an actual place. Might be in New Mexico. I might have to look that up. But at any rate, it heads north at 7 miles per hour after starting 75 miles south. The very slow southbound train leaves the station 47 miles north of Dirty Sock and heads south at the breakneck speed of 5 miles per hour. They are on the same track. I should note that. That's important for this story. When and where is the slow motion collision between these trains? So we can very easily come up with equations for this. We have two equations. We have an equation for the northbound train, which is going north at a rate or slope of 7 miles per hour. So there's my slope 7. Okay. And we have a starting point, which is often a y-intercept of 75 miles south. And since that's in an opposite direction, I'm going to use a negative for that. So y equals 7x minus 85. So I can plot a y-intercept if I like here. I'm going to have a y-intercept at negative 85. So 0, comma, negative 85. And then I will be going up 7 over 1, up 7 over 1, up 7 over 1, 4 points beyond this. I will find it useful to maybe pick a point that is, let's say, if I went to the right 10, I would go up 70 from there. So let's say we say 10 for x. So 10 times 7 is 70 minus 85. So that will be negative 15. So I'll have another point right there at, so these are a couple of points that I have on this line. And I can just draw a line through those 2 points. And I used my slope and my y-intercept to work out what a second point would be. So from 0, negative 85, I would have gone up 100, up 70, which would get me to negative 15, and then over to the right 10, because 70 over 10 is the same as 7. And you might notice I used points that were not right next to each other. I picked some that are a little further apart. So I can draw a line through those 2 points. And so I'll go ahead and do a rough line through them. Okay, so there's a line that is not perfect, but it will do the job for right now. So now let's take a look at the other equation. This other equation has a y-intercept at 47, so 0, comma 47. All right, now I can pick another point. Let's say I use 10 again. So if x was 10, that would be negative 50 plus 47. So that will be 10, comma, negative 3. So there's another point. And you can see they're getting kind of close to each other. And I label those. And I could draw another line through there as well. I'll use a blue one for this one. So I've got a slope of negative 5. That's pretty steep, but not as steep as the other one. So they're going to intersect somewhere in this area. Okay, somewhere in there. Now, I'm going to use Desmos to go ahead and really do a good job of graphing this. So I'm going to erase these lines that I've done because they're pretty sloppy in the utility that I have here. Okay, but somewhere in this area should be an intersection. Now, if I turn these equations on, you'll see I get that line, and I get that line. And there's going to be an intersecting point here. That intersecting point is going to be the solution for this system of equations right there. I click it. Desmos will just give it to you. 11, -8. Okay. If we were using and what you'll need to be using, of course, is the graphing space. So I'll go to graphing space general here, open that up. So you'll be needing to use this. Okay, and I need to change that to a solid line because currently we're dealing with equations, and I'll make a second one since we're going to need a couple of them. Won't need to worry about shading anything for now. So I'm going to move that out of the way because we don't need to worry about that. But I'm going to create an equation, a couple of equations right here. We'll have a couple of very simple equations that you could probably guess and check on. I think I need to make that point size a bit bigger. So we're going to have x plus, oh, that's really small, x plus y equals 13, and x minus y equals x minus y equals 1. Okay, so I could graph those. I'm going to make those, definitely make those bigger. So you can see what the heck I'm doing. These are very simple equations. The x and y intercepts for, actually, I think I need to change that from 13 to, we'll make it 9, because then it'll fit on this graph. The x and y intercepts for the first one are 9 and 9, so I'll plot those. So there's a y-intercept that's going to be 9. When x is 0, y will be 9, and I'll make a y-intercept, an x-intercept at 9 as well. So I can just grab this line and swing it around and graph it going through those points. Make it move a little bit. Okay, almost there. Now, I've got x minus y equals 1. In that case, the x-intercept, when y is 0, x will be 1. So I can plot that. I'll use red for that so I can tell the difference. The x-intercept, click on that. The x-intercept will be 1. There we go. And the y-intercept, if x is 0, the y-intercept, negative y equals 1, so y equals -1. So here we have a y-intercept at -1, and I can plot that one as well. So I'll plot that line, and where they intersect, where they intersect will be the solution of the system. So I'm just going to move it around until I get it right. And there, right there, should be the solution. Looks like we have a solution at 5, probably 5, 4. Now we're going to go back to Desmos and confirm this solution. So I'll zoom in here and we'll plot that. So x plus y equals 9, and x minus y equals 1. And there we have an intersecting point. That is a point that is shared by both lines in our system that we're considering both of these equations together. 5, 4 is the solution. So when you're doing level 1, all of the solutions are neat and tidy. They will go through, your lines will go through a very clear x and y intersection. There are other methods that we'll use when, say, the lines did not go through a neat and tidy intersection, and you need to work with fractions that are messier and so forth. I'm going to stop right now. This is what you basically need for level 1. If you are finding yourself fuzzy on how to graph the lines, Go back and review linear level 7 because that gives you everything you need for graphing the lines. This is going to primarily focus on slope-intercept form and standard form lines.